It began with a whisper of gibberish, a faint, indecipherable signal, almost like a cosmic hiccup, barely noticeable at first. In November 2023, Voyager 1, humanity's farthest explorer, started sending back a stream of nonsensical data. The spacecraft, which had faithfully reported from the edge of our solar system for decades, suddenly spoke in riddles. The telemetry was a loop of meaningless code. No science, no health, just digital chaos. It was as if the probe's language had been scrambled, its voice lost in static. At NASA's Jet Propulsion Lab, engineers stared in disbelief. Years of routine check-ins had never prepared them for this. Voyager was over 15 billion miles away. Every command took nearly 2 days for a round trip. The sheer distance made every attempt to fix the problem feel like shouting across a canyon. The probe was still transmitting, but it had lost its mind. Theories swirled: cosmic rays, aging electronics, a fatal glitch. Some wondered if the harsh environment of interstellar space had finally taken its toll. The corrupted data came from the Flight Data Subsystem, the FDS, the part that packages all data for Earth. Without it, Voyager was effectively mute, unable to share its discoveries. Pinpointing the cause was like finding a faulty wire in a house on another planet. The team pored over ancient schematics, searching for clues in decades-old documentation. For 5 months, silence from Voyager's science instruments. The spacecraft's sensors, once our eyes and ears in the void, had gone dark. The JPL team sent command after command, each a 46-hour wait, hoping for a coherent reply. Nothing worked. The silence grew heavier with each failed attempt. The mission that had survived Jupiter's radiation and the cold of deep space now teetered on the brink, undone by a single stubborn error. Years of triumph suddenly felt fragile. Humanity's longest-running conversation with the cosmos was reduced to a dial tone. The silence was deafening, a reminder of how easily our connection could be lost. The fragility of our reach into the universe had never felt so real. Every message, every signal suddenly seemed precious and precarious. The question hung in the air: was this the end? Or could Voyager's voice be restored one last time from the darkness? The breakthrough came from digital archaeology, not a quick fix. It was a painstaking process, requiring both technical expertise and a deep respect for the legacy systems built nearly half a century ago. The team had to think like the original engineers, piecing together clues from old manuals and faded schematics. Engineers sent a command to the FDS, asking for a full memory readout, a long shot, but their only hope. The spacecraft, drifting billions of miles from Earth, responded with a stream of data that was both familiar and troubling. Sifting through the garbled code, they found a fragment that didn't match the rest. It was like finding a single out-of-place note in a symphony, subtle but unmistakable to trained eyes. Careful analysis revealed the culprit, a single faulty memory chip, just 3% of the FDS memory, but critical. This tiny component had quietly failed after decades in the harsh environment of space. Its failure had corrupted the entire data stream, threatening to erase Voyager's ability to communicate with Earth. Fixing it from billions of miles away meant a software solution. There was no way to physically repair the chip, so the answer had to be clever, precise, and entirely remote. The team devised a plan: slice up the affected code and store it in healthy memory locations. This would allow Voyager to bypass the damaged area and keep functioning. It was digital brain surgery, performed remotely on 47-year-old hardware. Every command had to be perfect, every calculation double-checked, every step had to be perfect. A single error could silence Voyager forever. The pressure was immense, and the margin for error was razor-thin. Weeks went into writing and simulating the patch, working with ancient technology and incomplete documentation. The team often worked late into the night, fueled by determination and the knowledge that failure was not an option. The mission's fate rested on their ability to rewrite the mind of the machine. Voyager's continued journey depended on their ingenuity. They couldn't delete the broken code, so they had to outsmart it. The solution required creativity and a deep understanding of both old and new technology. The challenge: keep Voyager's brain working, even with a piece missing. It was a test of human ingenuity against the relentless march of time. The stakes: the survival of humanity's voice in interstellar space. Voyager carries our message to the stars, and its silence would be a loss for all of us. The solution was ready. Now it was time to try. The world held its breath as the team prepared to send the critical command. April 2024. the month that marked a critical juncture in the Voyager 1 mission. The team sent their software patch on its 23-hour journey to Voyager 1, hoping to revive the ailing spacecraft. The command moved the critical code to a safe memory location, a delicate operation requiring precision. Then came the wait. 2 days of suspense, filled with anxious moments and hopeful anticipation. On April 20th, a new signal arrived. The gibberish was gone, replaced by clarity. In its place, a steady stream of engineering data. It worked. The spacecraft was communicating again. The control room erupted. After 5 months, Voyager's vital signs were readable again, a monumental achievement. The spacecraft was healthy. The surgery had succeeded, but the mission was far from over. But the job wasn't done. Next, restore the science instruments, each crucial for ongoing research. Each new patch was a high-stakes operation, relocating more software to healthy memory, ensuring the instruments could function. One by one, the plasma wave subsystem, magnetometer, and others came back online, signaling a return to full operational capacity. By summer 2024, all 4 science instruments were restored, marking a significant milestone. The crisis was over. The team had pulled off a remote repair for the ages, a feat of engineering and teamwork. Voyager 1 was back, sending data from the space between stars, continuing its journey. The mission's survival was a testament to human ingenuity, perseverance, and collaboration. The lesson: it's not just the machines, but the people behind them that keep our journey alive, pushing the boundaries of exploration. Just as JPL celebrated, a new crisis struck. In October 2024, a routine command triggered Voyager 1's fault protection system. The spacecraft shut down all non-essential systems, including communications. For 2 days, Voyager was silent. No signal, no data, just the void. Engineers feared the worst. Had the patch caused a fatal error? Was Voyager lost? Then a faint signal flickered in, a heartbeat from deep space. Analysis revealed the truth. Voyager had switched to a backup transmitter unused since 1981. This ancient S-band transmitter was weak, but detectable. It was Voyager's way of saying, "I'm still here." The signal confirmed the probe was alive and its antenna pointed at Earth. More importantly, it could still receive commands. The team began carefully instructing Voyager to return to its primary systems. The 47-year-old spacecraft had saved itself with a 43-year-old backup. The mission was back from the brink, again. Even in crisis, Voyager's resilience amazed its creators. While Voyager 1 fought for survival, its twin, Voyager 2, quietly rewrote history. In 1986, Voyager 2's flyby of Uranus shaped our understanding of the ice giant, but a 2024 study revealed a twist: Voyager arrived just after a rare, intense solar storm. The storm compressed Uranus's magnetosphere and supercharged its radiation belts. The data wasn't wrong, but it was misleading. We saw Uranus on one of its worst days, not its normal state. This revelation upends decades of planetary science. Our models of Uranus's magnetic field and its moons may be based on an anomaly. The intense radiation Voyager measured might not be typical. Our only close look at an ice giant was skewed. We thought we knew Uranus, but we met its storm-tossed alter ego. The Uranus Anomaly is a cautionary tale. For nearly 40 years, our models were built on a single atypical snapshot. It's like judging a city by visiting during a hurricane. Now, scientists are re-evaluating decades of research. If Uranus's magnetosphere is usually weaker, everything changes, from atmospheric loss to moon chemistry. The implications reach beyond our solar system. Ice giants like Uranus are common in the galaxy. Our flawed model could mislead us about countless exoplanets. There's only one solution: we must return. A dedicated orbiter is needed to truly understand Uranus. The call for a new mission has never been more urgent. The universe is always more surprising than we imagine. The Voyager story is also one of slow decline. Both probes run on nuclear batteries, RTGs, that lose power every year. Launched in 1977, they started with 470 watts. Now, every watt is precious. Engineers have become masters of energy triage, shutting down instruments to keep the probes alive. The shutdowns are painful. Each is like saying goodbye to an old friend. In 2024 and 2025, key instruments on both Voyagers were powered down. The goal: keep at least one science instrument running as long as possible. Soon the priority will shift to keeping the transmitters alive. Even a faint carrier signal will be a scientific experiment. probing deep space itself. But the clock is ticking. The era of Voyager's grand exploration is ending. The slow fade is unstoppable. Now, every bit of Voyager data is more precious than ever. With power fading, each measurement is a glimpse we may never get again. The Voyagers are our only probes in interstellar space, tasting and listening to the galaxy itself. Every 46 hours, a new data packet arrives, each one a small victory. The data reveals cosmic rays, the galactic magnetic field, and the true shape of our sun's bubble. This is not abstract science, it's knowledge about our home and our origins. The cosmic rays Voyager measures are a hazard for future explorers. By studying them, we learn how to protect those who will follow. The Voyagers are humanity's advanced scouts. A small team keeps vigil, nursing these aging explorers. They carry the golden record, but their most important message is the data they still send. It's a message of discovery, resilience, and the unquenchable human desire to know what lies beyond. The Voyagers are more than machines. They're monuments to human ambition. Built to last 5 years, they've explored 4 planets and become our first emissaries to the stars. Their legacy is twofold: incredible science and a new perspective on our place in the cosmos. The pale blue dot image reminds us of Earth's fragility and unity. As their power fades, the Voyagers send a final message: a single flyby is not enough. The Uranus Anomaly proves the universe keeps its secrets well. To truly understand, we must return, stay, and observe. The Voyagers have shown the way, but they are just the beginning. The call for a new mission to the outer solar system is clear. We must build on their foundation. The Voyagers will journey on, silent ambassadors in the Milky Way. Their scientific mission is ending. It's up to us to answer the call and continue the adventure.